Hi, I'm Swarupa Sail, course instructor for Geotechnical Engineering 1. In this presentation, we will go through terminologies used to define degree of compaction, that is bulk density, unit weight, dry density, and dry unit weight. Then we will find out where compaction is done and benefits of it. Before going to the definitions of dry density and dry unit weight, we will check out how to find volume of soil. This is what is a soil sample which is collected in a mold of radius r and height h. Since soil is in this mold, the volume of mold itself will give us the volume of soil sample. Since it is a cylindrical mold, its volume is given by V is equal to pi r square into h. Hence, volume of soil sample is also equal to pi r square into h. Next, we will find out how to get the value of water content of the soil. Before that, we will check out the terms involved in finding water content. First one is M1, which is nothing but mass of empty container. This is what is the container which will be used to find the value of W. To begin with, container mass is noted down. Later on, wet soil sample is placed in the container. So, M2 is equal to mass of empty container plus wet soil. Then container along with the soil sample is placed in oven. After taking it out from the oven, its mass is weighed. So, M3 is equal to mass of empty container plus dry soil. With these three terms, we will be able to find water content. So, W is equal to M2 minus M3. M2 is mass of container plus wet soil and M3 is mass of container plus dry soil. So, M2 minus M3 will give us MW. MW is nothing but mass of water. M3 minus M1 is nothing but mass of solids. What is M3? M3 is mass of container plus dry soil and M1 is mass of empty container. Hence, M3 minus M1 will give us mass of dry soil or mass of solids. How do we define bulk density and unit weight? Bulk density is represented by rho, which is ratio of total mass to total volume. That is M by V. M is total mass, which is sum of mass of solids, mass of water and mass of air. Mass of air is equal to 0. Unit of density is kg per cubic meter. Dry density is represented by rho d, which is ratio of mass of solids to total volume. Hence it is written as ms divided by v. There is one more equation available to find dry density, that is rho d equal to rho divided by 1 plus w. Similarly, unit weight can be defined and it is denoted by gamma, which is ratio of total weight to total volume. Hence, gamma is equal to W by V, where W is total weight, which is sum of weight of solids, weight of water and weight of air. Weight of air is taken as 0. That is what we saw from soil as three-phase system. W is written as mass into acceleration due to gravity. But what is m by v? M by v is nothing but rho. Hence, it is replaced by rho. So, the equation for unit weight is equal to rho into g. What is unit of rho? It is kg per cubic meter, that is mass divided by volume. And what is unit of g? That is acceleration due to gravity. It is m divided by s square, that is meter per second square. 1 kg meter per second square is written as 1 Newton. That is, we know that weight is equal to mass into acceleration due to gravity. Unit of mass is kg and unit of g is meter per second square. Hence, 1 kg meter per second square is written as 1 Newton. Hence, unit of gamma is equal to Newton per cubic meter. Dry unit weight is represented by gamma d, which is ratio of weight of solids to total volume. That is Ws divided by V. Gamma d also can be calculated using formula gamma divided by 1 plus W. Now we will derive equations to find dry density and dry unit weight. Before that, let's recall soil as a three-phase system. Soil consists of three phases. One is air, second phase is water, and third one is solid particles. VA represents volume of air, VW represents volume of water, VS represents volume of solids. VV represents volume of voids, which is sum of volume of air and volume of water. VT represents total volume, which can also be denoted by capital V. MA represents mass of air, which is taken as 0. Mass of W is represented by MW and MS represents mass of solids. Total mass can be represented by MT or M. Hence, density is equal to total mass M divided by total volume V, that is M by V. But what is total mass M? Total mass M is sum of MA, MW and MS. But MA is equal to 0. Hence, M is written as MS plus MW and V as it is. How do we represent MW in terms of water content? We already have defined water content, that is ratio of mass of water to mass of solids. Hence, mass of water MW is equal to water content into MS. Hence, replace MW by W into MS. Rest of the terms as it is. Take out MS, which is common term. So, MS into 1 plus W divided by V is written. And mass of solids is represented in terms of dry density. We have already defined dry density. It is ratio of mass of solids to total volume. Hence, MS is equal to dry density into V. Hence, MS is replaced by rho d into V. And rest of the terms are written as they are. V and V will get cancelled. So, rho is equal to rho d into 1 plus W. Now, what will be the equation for dry density now? Dry density is equal to rho divided by 1 plus W. Similarly, we can derive equation for dry unit weight as gamma d equal to gamma divided by 1 plus W when weight is considered instead of mass in all these above equations. Now the question is where the compaction is done. Compaction is done during highway construction. Here we can see that there is a roller which is being used to compact the soil before laying the layers of the pavement. Compaction is done in order to remove air from the voids. And here we can see the construction of embankment. Embankment is nothing but it's a thick wall of earth which is built to carry road or railway lines, which is being constructed over an area of low ground to prevent water from river or sea from flooding this. And even while constructing earthen dams, they have to be compacted so that there is no seepage of water through the dam. During construction of airport also, the soil should be compacted well so that it can carry heavy loads. And here we can see earth retaining wall which is used to retain earth on this side. This soil which is being retained also has to be compacted well in order to prevent future disaster. Now we will find out what are the benefits of compaction. Compaction increases load bearing capacity of the soil. What do we mean by load bearing capacity? It is the capacity of soil to support loads applied to the ground. If the load bearing capacity of the soil is more than the load which is being applied on it, then the structure will be safe. If the load on the soil is more than the load bearing capacity of the soil, then there will be failure. Hence, the soil has to be compacted well so that its load bearing capacity increases. Otherwise, we will be observing the failure of the structure if the load bearing capacity is low. Hence, it is very important to compact the soil so that it can carry heavy load. Compaction also reduces settling. Here we can see the initial condition of a structure on a soft soil. As the time progresses, there will be settlement as it is soft soil, and this results in loss of building height. And here we can see that there is a drainage pipe below the pavement. Since it is a loose soil, there will be failure of the pavement due to settlement. If the soil is well compacted, there won't be any settlement of the soil and there also won't be any failure of the structure. Hence, it is very important to compact the soil to reduce settling. Compaction also increases stability of the structure. What happens is that if the soil is constructed on a clay soil, there will be differential settlement. That is, one part of the structure will settle more compared to the other part. If we compact the soil, there won't be any differential settlement. The Leaning Tower of Pisa is an example for differential settlement. In order to have better stability of the structure, it is very important to compact the soil. Compaction also decreases water seepage. Here we can see that there is failure of slope due to seepage of rainwater through the soil mass. So it is very important to compact the soil in order to reduce seepage of water into the soil mass. Compaction also reduces shrinkage. Soils which are rich in clay, they either undergo shrinkage or swelling. When clay type soil dries out, they shrink. So the lowering of the soil mass represents shrinkage. And when the soil is wet, it bulges or they swell. By compacting the soil, shrinkage can be reduced. Here we can see a retaining wall which is used to retain the soil. There is a gap before compaction. After compaction, the gap can be filled so that the retaining wall remains stable and failure can be prevented. Thank you.